and good morning. Okay. All right. Can see my screen.
Yes, Doctor.
All right. Okay. Okay. Let's start the lecture. All right. So previously we have looked at the 7 steps of catalytic reaction, and then we already go through for step 1 and step 2 on how the mass transfer of the reactant from bulk fluid to external surface of catalyst, and also how diffusion ataupun how pore diffusion occur on the active side of catalyst. Okay, now for today we will proceed with step 3, 4 and 5, because step 3, 4 and 5, which is adsorption, surface reaction and desorption, they relate with each other. So step 3, 4 and 5 relate with each other because it involves the adsorption of reactant to the active side of catalyst, and the reaction occur to form the product, and finally the product will dissolve from the active side. So these steps will truths, right? So for step 3, 4 and 5, it will involve actually there are 2 types of mechanism that we will consider for these steps, especially during the surface reaction step. And Lamor-Hishewood kinetic ni actually the kinetic that we use to determine on how the reaction occur, or we can say that actually it's not the kinetic but it is the mechanism. So the kinetic we determine it based on the mechanism of Lamor-Hishewood, and also another mechanism involved in the surface reaction, which is Illy-Rideal mechanism. Okay, so these 2 mechanisms will determine the kinetic of reaction, and these 2 mechanisms involved during the surface reaction, which is step 4. Okay, first we look at the Lamor-Hishewood kinetic. Why this kinetic is important? Okay, based on the Lamor-Hishewood mechanism, we can develop the rate law equation. So with the rate law, we can determine the kinetic of reaction. So the purpose of this mechanism is to develop rate law for heterogeneous catalytic by postulate the catalytic mechanism. Okay, so postulate the catalytic mechanism, meaning that we need to predict on how the reaction occur, or we need to predict the the pathway of reaction. Okay, and then when we have the mechanism of reaction, okay, and we need to derive the rate law equation. So basically, you kena buat assumption. Okay, you have the reaction, you know this is the reaction between this reactant, and then this is the catalyst, and the reaction occur heterogeneously in catalytic reactor and will form the product. Okay, you just know the general rate equation, but what is the mechanism of reaction actually occur on the active side of catalyst. So we need to predict the mechanism or propose the mechanism. And then based on the proposed mechanism, you derive the rate law. So maksudnya dia more to try and error method. And then macam mana kita nak provekan how to prove that the mechanism that we propose is correct? Usually you need to compare it with the experimental data. But that one more to those yang buat research. Okay, usually for postgraduate student, they do research on that. So they need to postulate the catalytic mechanism, derive the rate law and compare it with the experimental data. But at your level for this topic, we just learn how to postulate ataupun how to propose the mechanism of reaction and write the correct rate law equation. Alright, and then the mechanism of reaction ataupun the steps of reaction. So the different name for the mechanism, we call it as a reaction pathway or the steps of reaction. So the mechanism must consist of these three steps. Okay, mechanism consists of adsorption step, surface reaction step and desorption step. Okay, and then based on these three steps, okay, you will make an assumption on the rate limiting. Which step is the rate limiting? Either adsorption step, surface reaction step or desorption steps yang rate limiting, and this rate limiting assumption will determine the overall rate law equation. Okay, after we derive the rate law equation, we evaluate the rate law parameters. So yang ni yang saya cakap tadi, we need to evaluate the rate law parameters. How to evaluate the rate law parameters? We need to compare it with the experimental data. Okay, and then postulate the reaction mechanism and rate limiting. And when we have all this data, barulah we can simulate the reactor design. So basically, this step only to simulate the reactor design, especially in the industry. So in the industry, in order to design the reactor, they don't run the many run of reaction untuk dapatkan all the value and then you buat calculation. No, they run the simulation process. So based on the batch run of experiment, let's say they run only 2 or 3 run of batch experiment for the certain reaction. Okay, and then ataupun for catalytic reaction, they run 1 or 2 run of reaction or experiment. Then from the data, they evaluate and simulate it for in order to design the reactor. So dia tak akan buat sampai 100 run untuk obtain the experimental data, lepas tu nak design the reactor. No, it will take time. So cara paling mudah, okay, based on the preliminary study, based on the preliminary experimental data, okay, then they postulate the mechanism, postulate the rate equation, and based on that, the result we use to simulate the reactor design. Okay. So for step 3 is adsorption of reactant A to the active site of catalyst. Okay, so sepatutnya ada definition for adsorption ni. Adsorption is the step where the reactant will adsorb onto the active site of catalyst. So basically we know that adsorption can occur via physical adsorption or chemical adsorption. Chemical adsorption also called as chemisorption. Okay, so what is the difference between physical and chemisorption? Physical adsorption, it involves the exothermic process where the heat of adsorption is small and the force between the molecule between the gas molecule is very weak. Okay, so because of that, for catalytic reaction, it will not involve physical absorption because the attraction between the gas molecule very weak. So how the reaction will occur? Kalau for example as condensation process, yes, condensation process, it is a physical absorption. But for the reaction, for the process that involve the reaction to produce a new product, we call it as a chemisorption because it will affect the reaction rate. Okay, chemisorption will affect the reaction rate. So the adsorbed molecule or the adsorbed atom are held to the surface by valence force at the same type as those that occur between bonded atoms in molecule. So there is an interaction between the catalytic surface with the atom and molecule, and then the collision berlaku, and because of this collision the reaction will occur. How the reaction will occur? Okay, based on the collision between the molecule and the active site, the bond will easy to break. So dia ada bond between molecule and the catalytic surface. So collision kena berlaku. Okay, must be occur. The collision must be occur in order for the reaction to occur. Okay, so for catalytic reaction, it will involve the chemisorption process. Alright, now we look at the definition of adsorption isotherm. So adsorption isotherm ni, the isotherm ataupun the model that we can represent on how the adsorption occur. Okay, what happened during the adsorption and what is the isotherm on how the adsorption of reactant onto the active site of catalyst occur. So before that, we look at the definition of the term that we are going to use in order to write the adsorption reaction ataupun adsorption rate equation. Okay. Sorry. So before we derive the adsorption rate equation, we need to know all the terms involved during the process. Okay, first we have active site. So active site, we can write it as a S. So we represent active site as S, capital S. And then for the reactant, either it is atom in terms of atom or molecule or atomic combination, we can write it as A. But if you want to write it in terms of a different letter, let's say you want to write it in terms of reactant P ataupun reactant S, it's reactant S, it will confuse with the active site. So let's say reactant D, boleh juga. So if kalau you tak nak tulis reactant, simbol dia A, you can choose another letter yang selain yang listed in this slide. Okay, because kita tak nak confuse. Kalau reactant you tulis SS, so it will be confused with the symbol of active site. Okay, and then we have the term A.S. What A.S? A.S here is the reactant in terms of atom or molecule that absorb on the active site. So the species A absorb on active site S. We write it as A.S. CT, C here is the concentration. Okay, capital C, T, okay, subscript T. What is the definition of CT? CT is total molar concentration of active site per unit mass of catalyst. So we have the active site S, and then the total concentration we write is as CT. Okay, S here active site untuk kita tunjuk in terms of its reaction ataupun mechanism. But when we do the calculation in terms of concentration, so concentration of active site is CT, total molar concentration. And then we also have CV. What is a CV? CV is the molar concentration of vacant site. Total, sebenarnya total molar concentration of vacant site. So again, sama juga dengan S. Because active S ni, active site ni not only one. It can be more than one. So overall concentration of the active site either with the adsorbed reactant ataupun vacant site, we write it as CT. Vacant site, CV for the concentration. And then we have partial pressure of species I in gas phase. Okay, because we only look at the gas phase reaction for catalytic reaction, for heterogeneous reaction. So the reaction involve gas phase reaction. So usually in when you write the rate law equation, okay, you write it in terms of concentration, negative RA equal to KCA. But for gas phase reaction, we write it in terms of partial pressure because we can relate the concentration with partial pressure with ideal gas law equation. So for this topic, we will write the concentration for the reactant in terms of its partial pressure, PI. So kalau you ada reactant A, it will become PA lah to represent the partial pressure of reactant A. And then CIS, so again we have the concentration. This is the concentration for the adsorbed species. So yang tadi kita tengok A dot S as the adsorbed species. Therefore, the concentration for this A dot S equal to this term C A dot S. I ni dia represent any species. Okay. So kalau you ada species B, jadi PB. Here yang adsorbed species jadi B dot S. Therefore, the concentration C B dot S. So later we will look at on how to write, on how to use all these terms. Alright, the first example here, okay, for the adsorption isotherm. Okay, example 1, adsorption of A on a site S. Okay, this is the example for adsorption of one reactant. If the reaction only involve one reactant, so this is how the adsorption occur. Right. So where the mechanism of adsorption is A plus S reversible reaction A dot S. Adsorption step must be occur via reversible reaction. So adsorption step must be reversible. Okay, if you look at the diagram, so you have the reactant A. So reactant A adsorb on the active side of catalyst. So bermaksud 1A required one active site. So that's why the mechanism becomes A plus S because you only have 1A. Okay, 1A attached to the one active site A plus S. Reversible reaction to produce the adsorbed species A dot S. So yang dotted line, red color dotted line ni, the adsorbed species onto the active site. Okay, and then what is the site balance? Site balance, we want to write it in terms of its concentration. CT, total site balance concentration is CT equal to CV because we still have the vacant site here. This is the vacant site. Okay, or active site yang vacant. Plus concentration of the species that attach to the active site ataupun concentration of adsorbed species. So this is the site balance. We only have one species that absorb on the active site. Okay, so this is for the first example. Now we look at the second example, absorption of two species. We have two reactant here, which is A and B, on site S, represented by, okay, first we look at the mechanism here. Okay, so the mechanism is A plus S reversible reaction to produce A dot S. Here, this part. Okay, reactant A adsorb on this active site, reversible reaction to produce A dot S. Similar for B plus S, because only one A and one B. So it required only one S. B plus S, reversible reaction B dot S. Okay, and then next we need to write the site balance. When we write the site balance, okay, CT total concentration of site balance equal to CV. Okay, CV ni total molar concentration of vacant site. Jangan tengok gambar ni. Gambar ni diagram ni just for you to understand how the absorption occur. Okay, CV, even though gambar ada dua, kita tak tulis as 2CV. No, salah konsep tu. So CV is the total molar concentration of vacant site. So similar with CT total molar concentration. Total molar concentration CT ni is CV plus the concentration for all species that absorb onto the active site. So that's why CV ni we just write is as a 1 CV. Okay, and then plus the concentration of adsorbed species. So for this example, we have two adsorbed species, CA.S and CB.S. Okay, until here, boleh follow ke tak boleh? Or you have any question?
Boleh doktor.
Ya, boleh. Okay, boleh. Ha? Take 5? Kejap. Buku apa ni? 10.35. Okay, kejap. So, sekarang tak ada take 5 dah tau. Banyak lagi ni. Walaupun slide dia macam ni, tapi explanation dia banyak. Sekarang tak ada take 5 dah. Okay, sampai 10.40 and then we proceed sampai 11.30, okay? Right. Okay. Boleh proceed?
Boleh doktor.
Boleh.
Okay. Okay, so tadi dah tengok how the absorption, example of absorption. Now we look at the type of absorption, how the absorption occur, how the chemisorption occur. So yang lain ni, mana yang saya tak sebut ni just for your information so you can read on your own. Okay, there are two types of absorption. First is the molecular absorption or non-dissociated absorption. So maksudnya molecular absorption ni, the reactant they absorb as a molecule. Okay, for example here we have carbon monoxide. Disappointed. Okay, so we have the carbon monoxide. Carbon monoxide is the reactant. So this carbon monoxide will absorb as a molecule. So if the reactant absorb as molecule, we call it as a non-dissociated absorption or molecular absorption. So one CO required only one active site S, okay, reversible reaction to produce the absorbed species CO.S. Okay, and then another type of absorption, we call it as atomic absorption or dissociative absorption. So again, we still have the same reactant, which is CO, okay, gas CO, but it will absorb as a atom. So if the CO absorb as atom C and atom oxygen, it will require two active site. Okay, so that's why CO plus 2S here. Reversible reaction to produce C.S plus O.S. Because C will absorb on different active site, O absorb on the different active site. That's why it's required 2S. Okay, now we look at on how to write the rate of absorption. So when we talk about rate, of course we need to derive the rate equation, rate absorption equation. So how to write the rate, the net rate of absorption. So if you look at the mechanism here, so mechanism involve reversible reaction, reversible mechanism. Of course, it's similar with on how to write the reversible reaction rate law equation. You dah belajar dah in your Che502 and also during your first year, I think in subject chemistry code. So you already learned about it. So for the net rate of absorption, rate of attachment to the surface minus rate of detachment from the surface. So what is the rate of attachment? What is the rate of detachment? Rate of attachment ni similar with rate for forward reaction. Okay. And for rate of detachment, similar with rate for backward reaction. So the assumption that we use to obtain the Lamuir isotherm, okay, for absorption isotherm ni we also call it as a Lamuir isotherm. So we need to consider the surface of catalyst. So apa yang kita nak tengok on the surface of catalyst. So later we look at the type of catalyst that we use, the surface type of the catalyst, and also the absorption system. So absorption system ni yang tadi tu lah, either it is molecular or non-dissociative or dissociative, or ataupun we call it as a atomic absorption. Okay, so first example, we look at the non-dissociated absorption. Consider the absorption of carbon monoxide molecule. So this is the mechanism on how the reaction occurs. So carbon monoxide molecule required only one active site, reversible reaction, CO.S. So this is how the adsorption occur. The rate of attachment of carbon monoxide molecules to the active site on the surface is proportional to the number of collision that these molecules make with the surface active site per second. So tadi saya dah cakap, because of the collision between the molecule and the active site, there is a that's why adsorption can occur. So without the collision, there is no adsorption. So the collision rate is proportional to the partial pressure PCO. Okay, again, the reaction involve gas phase, the adsorption of gas CO. So we represent it as in terms of its partial pressure PCO. Carbon monoxide molecule adsorb only on vacant sites, and the rate of attachment is proportional to the concentration of vacant site. So yang ni kita nak tengok kat mana? We look at the rate of attachment and also the rate of detachment later. Thus, the rate of attachment to the surface is proportional to the partial pressure and the concentration of vacant site. So rate of attachment, this is for forward reaction. Rate of attachment for forward reaction, Ka. A here is adsorption, not for the reactant. Okay, K subscript A here is the adsorption, or kalau you tak nak confuse, you can write it as a AD. So you will not be confused with the reactant A. So nanti saya tunjuk contoh. Kalau dalam example, I wrote it as a KAD. So sebab saya tak nak confuse with the reactant A. So I wrote it as KAD. So dia jadilah adsorption. Okay, KAPCO. So because yang ni gas gas CO, so we write it in terms of its partial pressure PCO, and then CV. So dalam rate kita kena express in terms of its partial pressure, and for vacant site in terms of its concentration. So concentration of active site here CV, because only one S required, that's why CV power of 1. Sama juga dengan partial pressure of CO power of 1. Okay, yang tu for forward reaction. Now for detachment is backward reaction. Rate of detachment of CO molecule from the surface usually proportional to the concentration of sites occupied by the adsorbed molecules. So rate of detachment equal to K underscore AD, okay, ataupun KA. So in this case, A here is adsorption lah, reverse from the adsorption is desorption. So K minus ni merujuk kepada reverse reaction, reverse of adsorption, which is detachment. CCO.S. So CCO.S ni comes from this term. So yang ni adsorbed species CO.S. So we express it in terms of its concentration. Okay. Okay, and then itu baru kita tengok one by one. Tapi when you solve the question, no need to write the rate of attachment equal to apa, rate of detachment equal to apa. Yang ni just to remind ataupun kita nak refresh balik on how to write the rate law equation for reversible reaction. Usually, to answer the question, just directly write the net rate of adsorption. So this is the net rate of adsorption, rate of attachment minus rate of detachment. So RAD here, RAD is rate of adsorption, okay, equal to the rate of molecular attachment to the surface minus the rate of detachment from the surface. So this is the equation. Yang ni yang most important part at this part. Okay, and then we relate it with the thermodynamic terms. Okay, we can relate it with the thermodynamic for the rate constant. Rate equilibrium rate constant equal to, ataupun in this case adsorption equilibrium constant Ka, or you can write it as a capital K AD, equal to rate constant for attachment rate constant divide with detachment rate constant. Okay, and then because of this thermodynamic relation, we can simplify this equation. Dia jadi this equation. Write it in terms of its absorption equilibrium constant. So, rearrange the equation ni, you dapatlah this equation. Okay. Okay, so this is the thermodynamic relation with temperature, rate constant ataupun apa the rate constant for the attachment is independent of temperature, but rate constant for detachment increase exponentially with increasing temperature. But the equilibrium absorption rate constant decrease with increasing temperature. Sebab kenapa dia decrease? Because due to this relation. Yang ni increase with temperature, so automatically lah equilibrium rate constant decrease with temperature. So we need to relate it with the Arrhenius equation. Okay, and then bila dah tulis all this rate of absorption, you dah dapat the net rate of absorption. Again, we write the side balance. Side balance tadi CT equal to CV, even though dalam dia punya mechanism ni yang nampak active site required je. Tak nampak pun vacant site. So, but vacant site always available. That's why when we write the site balance, CT equal to CV. Yang ni must have in the equation. Okay. And then plus the concentration of the absorbed species. Okay, then at equilibrium, RAD, rate of absorption, equal to 0. That's why rearrange, you will get this equation. And then solve CO.S, kita nak solve yang mana, and the partial pressure. So yang ni saya akan tunjuk nanti dalam contoh. So this is the absorption isotherm for the absorption of CO.S. So dekat absorption step sahaja yang ada absorption isotherm. So this is the absorption isotherm for the absorption of carbon monoxide. Okay, ini belum lagi overall rate law equation. Kita baru step absorption. So during the absorption step, we can derive the absorption isotherm for the adsorbed species. Okay, kalau rate reaction lain, yang tu later, next week baru kita tengok. So for today, we just look at the absorption isotherm and then how the absorption occur, how the surface reaction occur. Okay, so before we proceed, we look at the first example. Okay, right. Untuk non-dissociated. Okay, yang sama, example yang sama. So tadi I already explain on how to write the rate law. So ini contoh. You have the mechanism, let's say mechanism of reaction given, ataupun you know the reaction CO to produce apa. Okay, so this is the absorption step. This is for the absorption step. Absorption, the CO absorbed as molecule. So it require only one active site. So you dapatlah mechanism yang ni. And then terus you directly write the net rate absorption. RAD equal to KAD PCO/CV minus CCO.S per KA. So this is the net rate absorption. So kalau macam tak, macam still confused nak tulis in terms of equilibrium absorption constant, you boleh buat start with apa tu yang ni tadi. Mana dia? Yang ni. Okay. Tulis yang ni dulu pun tak apa before you write it in terms of equilibrium rate constant. Okay. So kalau dah biasa, just directly write the rate absorption equation in terms of its equilibrium. Okay, and then write the side balance tadi. Okay, so start from here. At equilibrium, okay, yang ni nanti ada juga video saya bagi. Okay, video untuk on how to derive the absorption isotherm. Okay, at equilibrium, negative RAD, yang ni lah. Okay, even though dia yang ni tak tulis negatif pun sebenarnya negatif sebab dia rate kan, rate based on the apa tu disappearance of a CO. So negative RAD equal to 0. Okay, when negative RAD equal to 0 ataupun RAD ni equal to 0, automatically this term KAD equal to 0. And the term inside the bracket also equal to 0. So yang dalam bracket ni pun equal to 0. Okay, when this term equal to 0, just rearrange je. Rearrange for the adsorbed species. Okay, we rearrange for the adsorbed species. So dapatlah CO.S equal to Ka PCO CV. Okay, then next step, after we rearrange for the adsorbed species, we want to eliminate the term CV. Okay, when we write the overall rate law equation ataupun we want to write the absorption isotherm, rate of absorption ke, we want to eliminate CV. So the final equation mesti tak ada term CV. So that's why we want to eliminate CV. Tak nak ada term CV tu. Okay, so how to eliminate CV? Okay, so we need to write the side balance. Relatekan this equation with side balance. Okay, so this is your side balance. CT equal to CV yang asalnya apa? CT equal to CV plus CO.S. So tadi kita dah derive CO.S as this equation. So first step, okay, insert this equation into the side balance. So CT equal to CV plus Ka PCO CV. Okay, now simplify the equation. Kita kumpulkan CT equal to CV in bracket 1 plus Ka PCO. Then rearrange for CV. Dapatlah CV equal to CT over 1 plus Ka PCO. So now we have the CV equation. Okay, when we have the CV equation, insert back into the ni tadi apa tu adsorbed species equation. Yang ni CV, kita nak eliminate this CV. So kita cari what is CV equation, insert back into this equation. So that's why saya tulis insert equation 4 into equation 3. Therefore, so this is the absorption isotherm for carbon monoxide. So dah tak ada lah term CV. So kita dah berjaya eliminate the CV term. So this is how you derive the absorption isotherm for the absorption of carbon monoxide. Okay. Okay. So later saya postkan video example yang tadi tu yang saya tunjuk dalam PDF tu, dia sebenarnya saya buat dalam bentuk video, so you can watch the video and then try to buat the derivation on your own, baru you boleh nampak step by step macam mana you nak write the net rate of absorption sampailah you derive the absorption isotherm. Okay, right now we look at the dissociated absorption. So the step still the same. Okay, for dissociated desorption, first step we write the net rate of absorption. So saya dah terus dah the net rate of absorption. So equation dia yang tadi tu, CO plus 2S equal to C dot S plus O dot S. So dalam contoh, dalam PDF file ada saya tulis detail sikit lah compared to the notes. Okay, and then relatekan dengan thermodynamic relation for the absorption equilibrium rate constant. Okay, so you will get Ka PCO CV square minus CO dot S C dot S per Ka. Why CV square? Okay, kita tengok kenapa CV square? Because of this. CO plus 2S equal to C dot S plus O dot S. And all equation we assume it is elementary. Okay, elementary reaction. So that's why when we write the net rate of absorption, so Ka PCO, okay, partial pressure of CO, CV square, sebab yang ni required for this absorption is required 2 vacant site. So PCO CV square, we assume it is elementary. Okay, minus C dot S CO dot S over capital K A. And then sekejap apa dia, okay, saya terus tunjuk dalam ni lah, yang ni sama je dengan ni. So saya tunjuk terus dekat details dia dalam PDF ni yang dari video. Okay, and then side balance CT equal to CV, remember CV always available, plus CC dot S, the absorbed species is CC dot S and CO dot S. Okay, next, at equilibrium, RAD equal to 0. Nak letak negatif pun boleh, tak letak pun tak apa, tak salah. Okay, and then when RAD equal to 0, Ka equal to 0. And the term inside the bracket also equal to 0. Okay, and then rearrange for the adsorbed species. So in this case, we have 2 adsorbed species, CC dot S, CO dot S. So it's equal to Ka. So rearrange baru dia boleh dapat this equation, Ka PCO CV square. Okay. Now until this step, macam mana kita nak solve kan? Because we have 2 adsorbed species. So CC dot S, CO dot S, so let's say we assume that the concentration for both species, CC dot S and CO dot S, are equal to each other. So if the concentration C dot S dengan O dot S equal, so this equation becomes, so yang ni dah jadi apa? CO dot S square, because the concentration is still because the concentration for both adsorbed species equal. So CO dot S square equal to Ka PCO CV square. Okay, then next, when we assume the concentration for C dot S and O dot S similar, now your side balance becomes, so that's why saya tulis equation 2. Equation 2 ni tadi, from the side balance. Okay, so these two species sama, dia punya concentration sama. That's why side balance becomes Ct equal to Cv plus 2Co dot S. Okay, kenapa? Why we choose CO dot S? Because we want to write the absorption isotherm for the adsorbed oxygen. But if you want to write for the adsorbed carbon pun should be no problem. So you derive lah for adsorbed carbon. Dapatlah C dot S, 2cc dot S. So it depends apa kehendak, what is your requirement ataupun the question punya requirement. Okay, so in this case, I choose, I want to write the absorption of oxygen. So for the absorption oxygen, that's why saya solvekan untuk oxygen and eliminate term carbon. So this is your side balance, new side balance. Okay, and then from equation 4 ni tadi, because CO dot S square and then ada term CV here, we want to eliminate this CV. Okay, how to eliminate this CV? Okay, first step, solvekan dulu, jadikan what is the CO dot S equation, because ada square kat sini, so kena buat square root lah. So we can solve the equation for the adsorbed species. Okay, dapat equation 6. This equation insert back into the side balance equation. Masukkan dalam side balance. Okay, you will get this equation. Rearrange for CV. Okay, so dia banyak, this is the derivation step. So rearrange for CV. Then when you have the CV equation, insert back into the adsorbed species equation, which is equation 6. Because we want to eliminate this CV. So that's why saya buat anak panah macam-macam, anak panah insert to sana, insert to sini. So insert equation 7 into equation 6 into this equation because we want to eliminate CV. So this is the adsorption isotherm for adsorption of oxygen. So later, you watch the video and try buat balik, redo balik the derivation, baru you boleh nampak macam mana you dapat the final equation as this equation. Okay, so kalau dalam nota ni dah banyak skip, you tak nampak, so you kena tulis balik, redo balik. Okay. Okay lah, saya bagi rest 2 minit before we proceed with surface reaction. Surface reaction ni pun banyak melambak. Okay, kita break sekejap for 2 minutes. Okay, so we continue with the surface reaction. Okay, untuk surface reaction model, it will involve two mechanism. So that's why saya tulis tadi ada Lamur-Hissien-Wood mechanism and Ehlers-Danlos mechanism. Okay, Ehlers-Danlos mechanism is different from Lamur-Hissien-Wood. Okay, surface reaction model. Okay, we start again. We look at the absorption step because the surface reaction mechanism ni depends on how the absorption occur. So let's say from the absorption step tadi, okay, 1A react with 1S to produce A dot S. So only one adsorbed species involved in the reaction, meaning that we only have one reactant. And this is the net rate of adsorption. Then the adsorbed species will proceed to the surface reaction to form a product. The reactant that has been absorbed onto the surface will react in a number of ways. Okay, minor pointer, right. So it can react via single site mechanism, dual site mechanism, or Ehlers-Danlos mechanism. Okay, for single site and dual site mechanism, we call it as a Lamur-Hissien-Wood mechanism. And then Ehlers-Danlos mechanism, they stand alone. So Lamur-Hissien-Wood can be occur via single site mechanism or dual site mechanism. Okay, how to determine either it is a single site mechanism or dual site mechanism? Right. First, we look at the single site mechanism. Okay, if during the adsorption only have one adsorbed species, okay, only the site on which reactant is adsorbed is involved in the reaction. That's why we need to look at the adsorption step first. So only the site on which reactant is adsorbed is involved in reaction. So A plus S to produce adsorbed species A dot S. So the reaction mechanism is elementary in each step. So sama juga, we consider it is elementary step. There's the rate law mechanism dulu. We look at the mechanism dulu. How the surface reaction occur before we look at the rate law. So this is the mechanism. The adsorbed species, reversible reaction to produce product B dot S. So the product still adsorbed on the active site sebab belum berlakunya desorption. So that's why the still adsorbed on the active site. And untuk surface reaction, okay, so kalau tadi adsorption must be reversible. The adsorption process must be reversible. But for surface reaction, it can be reversible or it can be irreversible. Dia boleh dua-dua, reversible or irreversible. So it depends on the system of reaction. So for this example, saya tunjuk reversible reaction dulu. So later next week we look at the irreversible reaction untuk surface reaction. So kalau adsorption, dia wajib compulsory to the process is compulsory to be a reversible adsorption process. But surface reaction, it can be reversible or irreversible. Right. So this is the reaction. So this is how the reaction occur. So the adsorbed species tadi from the adsorption step tadi, dia dah adsorb on the active site and then reaction berlaku. Reaction berlaku to produce the product B that adsorb on the active site. Active site yang sama, the same active site where the reactant adsorb. So dia akan produce the product at the same active site. So this is what we call a single site mechanism of Lamur-Hissien-Wood kinetic ataupun Lamur-Hissien-Wood mechanism. Okay. And what is the rate law equation ataupun rate reaction equation? So rate reaction dia, of course, sebab reaction berlaku, via reversible reaction. So reversible reaction, Rs equal to Ks C A dot S for the adsorbed species concentration lah. We express it in terms of its concentration. Minus Cb dot S because dia still dalam bentuk adsorbed species. Divide with Ks. Capital Ks ni surface reaction equilibrium constant. Sebab dia sama dengan reversible reaction yang you dah belajar in reaction 1. So this is how we write the rate law equation for the reaction. Okay. So this is for single site mechanism. Okay, next we look at the dual site mechanism. Dual site mechanism ada banyak. So how to determine either it is dual site or not. Okay, selain daripada kita tengok how many adsorbed species, we also can look at the reaction system. Okay, reaction system tu macam mana? Okay, the adsorbed reactant interact with another site, okay, occupied or unoccupied to form the product. Okay, during the surface reaction, so this is the adsorbed species. So during the adsorption tadi, only one species je yang adsorb onto the active site. But during the surface reaction, it required another vacant site for the reaction to occur. So that's why A dot S plus S. Sebab the reaction to surface, during the surface reaction, they require another vacant active site. Okay, and then reversible reaction to produce the product and plus S. Sebab apa plus S? Of course kena seimbang. Both right and left kena seimbang. Okay, so kena adalah remaining vacant site. But if you can look at the diagram here, so this is the during the adsorption process, the reactant adsorb at this active site. Okay, in order for the reaction to occur and form the product, they require another active site. Why? Because the product, after the reaction, the product tu dia produce and adsorb at another active site. Then leave it the other active site as vacant site. That's why we call it as a dual site mechanism. Even though during the adsorption ataupun even though the reactant dia only one, tapi during the surface reaction tu it required another vacant site. So maksudnya dual site ni berlaku during the surface reaction. Okay, and then the adsorb A react with an adjacent vacant site to yield a vacant site and absorb product site. So kita nak seimbangkan the equation, that's why both right and left kena ada S ni tadi. And because of why we need another vacant site during tu, sebab the product itself will produce at another vacant site. Okay, therefore, based on this mechanism, we write the rate of surface reaction as Rs equal to Ks in bracket. So the concentration of adsorbed species multiply with the concentration of vacant site minus concentration of the product yang still adsorb onto the active site multiply with the concentration of vacant site, remaining vacant site, divide with equilibrium rate constant for the surface reaction. So yang dekat surface reaction ni yang you dah belajar dulu masa reaction 1. Inilah yang berlaku. Okay, tapi bezanya the reaction occur on the active site of catalyst. Because this is the catalytic reaction for gas phase. And then another type of dual site mechanism. So yang first example of dual site ni kalau one adsorbed species tapi product produced at another vacant site. Kalau if the reaction involve two reactant, Okay, and then there are two adsorption step. Okay, kalau ada dua reactant and then ada dua adsorption step because both reactant will adsorb on the active site. So maksudnya during adsorption pun ada two steps of adsorption step. So first for the adsorption of A dot S and the second one the absorption of B dot S. So how this adsorption occur, yang ni we will look at it next week. So kita akan tengok overall reaction baru nampak bila ada two adsorb species. So for this example, it will involve two adsorption step, okay, adsorption of A dot S and adsorption of B dot S. And then during the surface reaction ada two adsorb species. So this is the adsorb species and the reaction will occur to produce product C and D. So kalau ada two adsorb species, if you have two adsorb species, automatically the reaction is dual site mechanism. Tu yang paling senang lah to determine either it is single site or dual site. So kalau ada two adsorb species, automatically it is dual site mechanism. Okay, and then you produce the product. Kalau satu je produk, A dot S plus B dot S, reversible reaction, C dot S plus S. If you only produce, if the reaction only produce one product. Okay, so dia akan leave vacant site S lah. So in this example ada dua produk. Okay, so it depends on the reaction. So similar for the rate of surface reaction. So this is the rate of surface reaction. We write it in terms of the adsorb species for reactant and also the product. So kalau only one product, so your product jadi minus CC dot S CV sebab dia leave vacant site dekat sini. Kalau tak ada produk D ni. So dia jadi CV here. So you kena banyak main dengan equation lah. Okay, and another example of dual site mechanism, again still for the two adsorb species, reaction of two species absorb on different type of site S and S dot. So S apostrophe and apa tu? S apostrophe lah. So kalau apa bezanya? So if you look at the diagram, the shape of catalyst ataupun the shape of active site different. So triangle and apa tu rectangle. So ini pun we call it as a dual site mechanism. Tapi still untuk two adsorb species, so automatically it is dual site mechanism. The difference only the shape of catalyst. So to differentiate the shape of catalyst, that's why kita letak tanda apostrophe dekat situ. Okay, tapi dia punya konsep still the same with two adsorb species. Okay, and finally, so tadi yang ni dual site dengan single site is Lamur-Hishewood kinetic ataupun Lamur-Hishewood mechanism. The kinetic tu dia punya rate. Okay, kinetic is a rate yang involve rate law equation and you want to determine the value of rate constant. So we call it as a kinetic. Tapi the mechanism is Lamur-Hishewood mechanism. Okay, and then Illy-Rideal. Okay, Illy-Rideal ni involve two reactant. Okay, tapi only one reactant yang absorb onto the active site. And another molecular reactant, it just involve during the surface reaction. So maksudnya even though you have two reactant A and B, so both dalam bentuk gas phase, both in gas phase, A and B gas phase, but only A je yang absorb onto the active site. So meaning that only one steps of adsorption. Okay, adsorption of species A. So bila dia dah adsorb, you will get this adsorption species A dot S. And then during surface reaction, barulah gas B ni. B, molecule B in gas phase involved in the reaction. So without B, there is no reaction to occur because the basic for the reaction to occur, it must have reactant A and B. So without B, tak adalah reaction berlaku. Tapi only A yang adsorb to the active site. Okay, B only involved during the surface reaction. So this is the surface reaction. How the surface reaction occur. So A adsorb on the active site as A dot S, and then during the surface reaction, it will reacted with gas B to produce the product C that adsorb on the active site and another side product ataupun side product D. So, how to write the rate law equation? So, Rs equal to Ks. So, based on the mechanism, CAS, A dot S, sebab B ni dia tak adsorb, so we write it in terms of its partial pressure. So, CAS PB minus CC dot S, and D pun dia tak adsorb, dia just dia be free. Okay, so we write it in terms of its partial pressure of the product, and divide with equilibrium rate constant for surface reaction. Okay, but if the reaction only produce one product, which is C, so the mechanism will becomes A dot S plus B, gas phase, reversible reaction to produce product C dot S. So maksudnya produk tu the adsorbed species. Okay, there is no gas D. So what will happen to the overall rate law for the surface reaction? Rs equal to Ks in bracket CASPB minus CC dot S over Ks. Sebab there is no product D. Tak ada gas D yang produce during the reaction. So just eliminate lah term partial pressure of D. Okay, so the difference only this part. Okay, there for iridial dia kena ada molekul gas yang only involved during the surface reaction. So that is how you can differentiate iridial dengan Lamur-Hirscherwood mechanism. Lamur-Hirscherwood mechanism, it can be single site or dual site. Okay, so dual site tu je yang you kena tengok how to differentiate the dual site. Either it is a dual site for one adsorbed species ataupun dual site for two adsorbed species. Okay, berapa dah? Oh, 11.5. Okay, this is the last slide lah. Right, last slide. Okay, desorption. So tadi saya cakap in order for the reaction to occur and for in order to to postulate the mechanism of reaction, the reaction must involve adsorption, surface reaction and desorption. Tapi ada certain cases desorption is negligible. So bila desorption negligible, maksudnya during the surface reaction, the product, okay, kalau desorption tak ada, so maksudnya yang compulsory now is the adsorption and surface reaction. If desorption is negligible, meaning that during the surface reaction ni, there is no product yang adsorb on the active site. So dia jadi produk yang bebas, dia free from the active site. Itu kalau tak ada desorption step. but usually ada. So later saya tunjuk example kalau ada certain reaction that not involve the desorption step. So for now we just consider all reaction involve desorption. Okay, desorption ni after you produce the product. Okay, the product of the surface reaction absorbed on the surface are subsequently dissolved into the gas phase. So tadi kita dah produce the product. So here, this is the product. Either it is single site ke, dual site ke, dia absorb on the active site. Dia still ada. So kita tengok yang paling senang single site lah. So for this case, okay, the product produce A.S ataupun yang produce C mana. Yang ni lah. Okay, you dapat product only C.S. Okay, let's say ada one product sahaja. So C.S ni dia still absorb on the active site. Okay, and then macam mana dia nak free? Of course via the desorption of via desorption process lah. So during the desorption, what happen? You will leave the product and the vacant site. Okay, therefore, so this is what happen during the desorption. Desorption tu dia proses yang reverse, macam proses yang reverse, but it is for the product. Okay, reversible reaction of the product. So you will get the product alone and also the remaining vacant site. So the rate of desorption RDC here, D meaning the desorption for the product C, equal to KD. KD ni rate constant for desorption step. Okay, in bracket CC.S, because they still absorb on the active site, onto the active site, so we can still write it in terms of its concentration. Minus, so sekarang the product dah free from the active site. So dia dah jadi dalam bentuk gas. That's why we write it in terms of partial pressure of the product C. Okay. Multiply with vacant site CV. Divide with the equilibrium rate for desorption of product C. And this equilibrium desorption constant, we can relate it with the thermodynamic. Okay, we can relate it with the adsorption equilibrium constant. Why? Because desorption equilibrium constant is reciprocal of adsorption equilibrium constant. So look at this equation. So this is the desorption equilibrium constant and it's equal to 1 over adsorption of product. K, capital KC ni, this is the adsorption of the product. KDC, desorption of the product. Therefore, this equation can be simplified as this equation. So RDC equal to KD, CCS minus KC. So this is adsorption of the product. Okay, bukan adsorption of reactant. Jangan confuse yang adsorption step tu. So this is for the adsorption of the product. Okay, KC, PC, CV. Okay. Alright. So any question sampai step 5 ni? Boleh follow? So after this, yang video explanation ni pun ada. So you can watch it again. And then bila you buat derivation tu, try redo the example for you to understand on how to derive all the equation. Okay. So ini baru sampai step kita tak masuk lagi overall rate law. So for next week, we will look at the synthesizing dengan rate limiting. So in order to write the overall rate law equation, we need to know which step is the rate limiting. Either it is adsorption step, surface reaction step, or desorption step yang rate limiting. So kalau you tengok nota macam ada berapa line je nota untuk rate limiting. Tapi explanation dia tak cukup 2 jam. Sebab dia ada banyak case. So next week saya akan tunjuk for each case. Adsorption rate limiting, surface reaction rate limiting, and then what will happen if surface reaction is irreversible. So dia ada banyak case study yang kita akan tengok. Okay, daripada from that baru you boleh understand on how to determine the overall rate law equation ataupun overall rate reaction for the catalytic reaction. So kalau tak ada any question, so saya stop presenting. Okay, then dah 9.40 dah pun, dah habis dah. Okay, so that's all for today, and thank you everybody and have a nice weekend. So if you have any questions, so after this saya akan terus post dekat classroom, and then if you have any question you can ask in the WhatsApp group. Okay, just capture the image which part yang you don't understand and then post dekat group, then I can explain it again, so another ataupun you punya kawan-kawan pun boleh tahu which part yang you tak faham, and then the rest will learn together. Right?
Alright.
Okay, thank you. Assalamualaikum.
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doktor. Thank you, Doktor.
Doktor.